Hi, I'm Bernard Leong, Head of AI/ML for ASEAN. Today, I will take you through how AWS can accelerate your digital transformation journey with document digitization. I'll be joined first by my colleagues Alex Tusi, who will take you through the technical demos specific to this segment of the webinar. Let's start with the why. Businesses create billions of documents every year to capture data for future search and discovery, compliance, and to facilitate future business processes. However, this massive influx of documents often results in a significant bottleneck when it comes to processing. Today, we see three main approaches to processing documents: manual, optical character recognition, or OCR in short, and rules template-based extraction, often as part of a robotic process automation, or RPA in short, process. This brings us to the challenges that any business would face with respect to document processing. One, it's extremely time-consuming, resulting in operational bottlenecks. This slows down your processes and takes up valuable employee time. Two, as employee time is valuable, spending a lot of time processing documents will translate directly to higher costs. Even worse, if you have a significant number of documents to process, you need to invest in a team to handle the process, which results in a high fixed cost and overhead. Lastly, even if the documents are stored in digital formats, how accessible is the data within? For business leaders such as yourselves, I would imagine that you often have to devote a significant amount of time looking around for the necessary information, time you wish could have been better spent. Another key issue that we often see is that businesses have records locked up in physical copies. This makes it even harder to use that data for analysis. McKinsey estimates that 20% of the time spent by employees are used in looking for information, while IDC estimates that 44% of the time employees cannot find the necessary information they need for their roles. This is pretty concerning, right? Hence, there's a need for change. And what are the challenges that come with previous document processing solutions? So let's look at some of the issues that are inherent with previous attempts to digitize documents. You are likely familiar with traditional OCR. Although OCR is able to read and understand words, it struggles greatly with different document formats and was thus error-prone. For example, if you were trying to scan a report, it may have embedded pictures or newspaper that may have been broken up into columns. OCR would disregard these formats and read across columns and pictures, resulting in a rather unusable flat bag of words. Next, we saw an emergence of robotic process automation. It promised to help organizations to automate tasks and promoted icon drag and drop menus instead of code. While this seems like a good idea in practice, there was a significant drawback. RPA was highly reliant on rules and templates. For example, if you want to extract data from an invoice from company A, you will have to set up a template to read that invoice, and you would still be unable to process invoices from company B and any of A's invoices that deviated from your rules. What many customers found as a result was that OCR and RPA were not practical because they couldn't adapt to non-standard formats. Making more and more rules and exceptions quickly became a complicated and expensive endeavor with limited chances of success. Thus, most decided to continue relying on manual processing, either in-house or outsourced. However, manual processing is inherently limited given its cost, inconsistency, and time required. Let's see how AWS can help you with document digitization with a set of solutions. First, let's tell you our mission for the AI/ML team at AWS. Our mission is to take our rich experience and expertise with machine learning across Amazon and put it in the hands of all organizations, every developer, data scientist, and researcher. We want to make it easy for all developers to easily build intelligent applications so that they can focus on their applications rather than having to sort out the complications of setup, training, and refining their machine learning models. Some people would ask, why AWS for machine learning? First of all, we provide the broadest and deepest set of machine learning and AI services for your business. AWS is unmatched in the breadth and depth of capability we offer for our customers. We launched over 200 new features and services in the last year, and no other provider has done more than half as many. And our pace is only accelerating. Your developers will love waking up virtually every day with new capabilities at their fingertips. Developers with no prior machine learning experience can easily build sophisticated AI-driven applications spanning computer vision, language, recommendations, and forecastings, many of which machine learning technology perfected from years at Amazon. Second, we can accelerate your adoption of machine learning with Sagemaker. Sagemaker is a managed service that takes a number of required steps to build, train, and tune and deploy a machine learning model and makes it easier for everyday developers and scientists. It helps organizations of all sizes to embrace machine learning. Before Sagemaker, doing ML was just too hard for many customers. By making machine learning easier at low cost, customers can make better use of their data, which is both valuable and differentiating. In less than 2 years, over 10,000 customers have adopted Sagemaker, and many of them have now made it their standard for machine learning. And we have recently launched Sagemaker Studio, that's fully integrated development environment for machine learning. This allows you to store and collect all the things that you need, whether it's code, notebooks, datasets, settings, and project folders, all in one place, one pane of glass. And it makes it much easier to actually manage those pieces in building a model. And what's up more, Sagemaker lowers TCO over a 3-year horizon by at least 54% compared to other cloud-based machine learning options, such as self-managed EC2 and AWS-managed EKS. Lastly, you can get the confidence of building on AWS, the most comprehensive cloud platform optimized for training. That is why if you look at today, 85% of Google's TensorFlow in the cloud runs on AWS. We have a lot of customers running it, and we have a team that does nothing but work on optimizing TensorFlow performance on AWS. The AWS machine learning stack is constantly growing. Regardless if you are someone who wants to use pre-built solutions or use your own, AWS provides the tools you will need. We want to come to tell you a bit more about the AWS machine learning stack. In the bottom layer are the frameworks and infrastructure for expert machine learning practitioners. In the middle layer are the machine learning services that make it easy for machine learning developers and data scientists to build, train, and deploy machine learning models in a single click with Amazon SageMaker. And in the top level, that allows all developers to use pre-trained and auto-trained models to add intelligence to any application without machine learning expertise. For document digitization today, there are a few key AI/ML services which are often used. They are Amazon SageMaker Ground Truth, Augmented AI or A2I in short, Amazon Recognition, Amazon TextTrack, Amazon Comprehend, and Amazon Kendra. Let's start with TextTrack. Amazon TextTrack goes beyond traditional OCR and rules-based extraction and can dynamically read documents much like a human would. It's able to read data from 3 different formats: basic text, tables, forms, and we will see that in the demo later. In summary, Amazon TextTrack can help you to extract data quickly, more accurately, eliminate manual effort, and lower document processing costs. Lastly, we do most of the heavy lifting for you. No ML experience is required. Although TextTrack forms the core of our document digitization capabilities, it is most effective when combined with the other service within the AWS machine learning stack. On this slide, I would summarize some of the key complementary services before we dive deeper. Kendra helps your employees to find the information they need, even if it's scattered through different databases and locations. This helps your employees quickly access the information they're looking for with simple searches. Comprehend is very often used with TextTrack to discover insights and relationships hidden within entire libraries of documents, allowing customers to increase the effectiveness of their research and find the mega trends that were previously too big to see. Amazon Recognition is our computer vision tool to identify people, objects, and activities from images. We've seen some of our financial services clients leverage this to automate their Know Your Customer or KYC processes by helping verify proof of identification to account holders. Any automated process will undoubtedly still require some human review. We provided Amazon Augmented AI to flag low confidence results for human review. Being ML enabled, A2I will learn as more and more edits and reviews are performed to improve accuracy and reduce the need for human intervention. Lastly, to start any ML task, you will need your data to be labeled. This is where Amazon Sagemaker Ground Truth comes in, providing a fast and cost-effective way to build accurate data sets. There are 3 use cases that we see most frequently when it comes to document digitization. First, many companies are still trying to shift from paper to digital records. They face the challenge of converting large libraries of physical documents into more accessible digital formats. Next, internal departments such as finance or HR often have to process a significant amount of forms, claims, and if we look at the banking and insurance customers, this is an operational necessity that directly impacts their turnaround times and customer satisfaction. Lastly, we have also seen Amazon customers enhancing their research capabilities. Research and compilation takes up employee time that could be better used. Document digitization can increase the width and depth of research efforts while making the data more readily available. Throughout this segment, we'll showcase some demos so that you can see what's possible. But just how impactful could document digitization be? To answer this question, let us consider a hypothetical example. Say we run an insurance firm that has to process claims over the course of the business. Now, let's assume that it takes, on average, 1 employee 3 minutes to process a claim into the system. 1 employee times 1 document equals 3 minutes. But now, let's scale things up. This is quite an established firm, so we are dealing with about 5,000 incoming claims and inquiries per day. That's 15,000 minutes or 250 hours worth of claims per day. Also note that employees will tire quickly from doing so much repetitive work, resulting in an increased probability of errors. If we devote a full-time team on this, we'll be looking at 50-man team working 5 hours daily on processing. You can already start to imagine how much this is going to cost. At a rate of $10 per employee hour, you'll be spending $2,500 daily or short of just $1 million yearly to process claims. Note that with a 50-man team, you will also have to scale up management, which incurs more fixed cost overheads. This was just a hypothetical example, but just think which segments within your business have to process thousands of documents or even maybe hundreds of thousands, and how much is this costing you? To automate claims better, let's look at a reference architecture that breaks down the process from end to end. At the input stage, users can capture photos of their claims and forms to be uploaded to the application. At this stage, we can use Amazon Recognition to identify problematic images, prompting users to retake the photos to prevent the need for manual review, further requests further down the line. We then use TextTrack API to extract the text from the form and auto-populate the fields. At this point, we have 2 choices. We can either have the customer experience the form be digitally populated in real time, or have the low confidence results sent for human review using Amazon A2I. This really depends on the business needs of the use case. Finally, the data is compiled and sent to a database. Additionally, the original picture can be stored as an S3 object for verification and audit purposes. I will now hand over the time to Alex Tusi, our AI/ML solutions architect, to demonstrate how these architectures could look like in a real application. Alex, over to you.
Thanks, Bernard. So let's look at an example use case in receipt digitization. And to get started, we'll dive into the Amazon TextTrack console and use the Try It Out panel to get a feel for what the service has to offer. Now I'm going to ignore the document that loads in by default and instead upload this photograph of a receipt. And one of the first things you might notice here is that the image is pretty poorly conditioned. We've cropped out quite a lot of the content that we might be interested in. You can see that the text is all aligned on quite a strong angle, it's quite skewed here. And if we scroll down to the bottom, we can also see that the edges of the receipt have curled up, which has introduced a bit of curvature into some other content. So here in the console we can see the text, which Amazon TextRact's been able to extract from the document. And that's at the line level by default, but we can also drill down to individual words if we prefer. And as you can see from the visualization, we have access in the result not just to the text itself, but also to the bounding boxes where each one of these elements was detected. And in fact, if I went and searched through the download results JSON, I could also find confidence scores for each one of these elements here, reflecting how confidently TextRact was able to interpret the text that it found there. Looking at the extraction overall, we can see that performance has generally been pretty good, considering the challenging nature of the image, but there are still one or two issues which might indicate where we could struggle. One I'd like to mention is down here at the bottom, we've been unable to extract this leading 1 at the front of the date here. And so you can see the combination of this text being quite heavily skewed in the first place, and then the curvature introduced by this corner curling up here has made this region quite challenging to read overall, with the result that we have a minor transcription error here, which could still have a significant business consequence, particularly because it could still be recognized as a valid date. So one of the first things we might think about when introducing Amazon TextRact into a business process is whether we have some pre-processing layer before our OCR itself. That might be a simple validation check where we detect and reject poor quality images before they go any further into our processing pipeline. It might be something a little more advanced where we try and use image processing techniques, for example, to work around minor quality issues, maybe correcting for blur, improving the contrast, or detecting and correcting for skew. Or it might be some business process level task where perhaps we have a process capable of ingesting different document types, and we need to understand from the image which document type we've been shown so that we can interpret it correctly downstream. Maybe I'm processing both small receipt documents like this, but also bigger invoice-style receipts from hotels and so on. Or maybe I'm looking at an identity document use case and seeing things like passports, driving licenses, and ID cards, having to handle each one of those slightly differently. One great tool to bear in mind for these kind of pre-processing use cases is Amazon Recognition custom labels, which allows us to build custom computer vision models without any experience in machine learning required and without having to do any coding. Over here in the custom labels console, I've uploaded some example images with a good quality where we can see that the receipts are well defined, they're lined up well with the image itself, and the contrast should be sufficient for us to do some OCR. And then I've tagged some separate images as bad quality because maybe they have issues like not featuring a receipt in the frame at all, perhaps they have this sort of skew and cropping that we've seen in the last image, or maybe they have other problems like poor lighting or blur. Now, Amazon Recognition is a general-purpose computer vision service capable of analyzing both videos and images and doing a wide range of annotation tasks, from things like object detection and localization in scenes, to face recognition, detection, identification, analysis, to content moderation, activity detection in video, and so on, others besides. However here, rather than those public models, we're using the custom labels functionality to build custom models for our particular use case, because we'd like to draw this quite fine distinction between similar classes of good and bad images of receipts. So here we're benefiting from the engineering behind Amazon Recognition and the expertise in computer vision there, but applying it to our own data sets to build this business case specific model. So assuming that we're able to handle our quality control problem, we should end up with a little bit of a better quality input, maybe something more like this. And our question will become, how do we extract the content that we care about from these receipts? And so you can see over here on the right-hand side, in addition to the raw text, TextRact is giving me these two other structured extraction tools of forms and tables. For tables, on this particular image, we've been able to extract this two-column table section, spanning both the list of line items in the bill and also the summary area down at the bottom with subtotal and tax and other things and the final chargeable amount. Now, for a larger and more formally structured document type like an invoice, we might reasonably expect to extract two separate table areas, successfully capturing this first quantity column area and separating out this list of line items from this summary area at the bottom. Unfortunately, that's not been the case for this small document type because everything's a little bit cramped onto a receipt and the structure isn't terribly well defined. But in general, tables can be a really valuable tool for interpreting documents where tabular structure is really important to the content that we need to extract. For our particular use case, we really only care about 3 top-level fields though: the vendor, the date of the transaction, and the total amount paid. And for use cases like that, forms functionality is going to be much more interesting to us. In forms, we see key value pairs which TextRact's been able to interpret from the document. For example, the tax registration number of the restaurant, the table number, and further down, some important fields like the subtotal, the service charges, and the grand total. Now, the important thing to bear in mind with both the forms and the tables functionality is that these are driven by the verbatim text of the document. For example, you can see here that there are brackets around the GST registration number key value pair, that there's a colon in the table number section, but not, for example, in the subtotal section. And that's because TextRact is providing us general purpose structured extraction tools to use across a really broad range of use cases. And so there's no assumptions baked in here as to what's important and what's not important relative to our verbatim content. For example, even in this document, you can see why it might be unwise to ignore small punctuation elements like brackets and colons, because here in the rounding key, we're using this bracket notation to indicate a negative number. For our use case, different phrasings of grand total, like total or amount payable or final total, might all correspond down to the same business level field: how much was the receipt worth? Whereas if we consider more advanced use cases, perhaps including medical insurance invoices, we might have very different meanings between a total charges and an amount payable field, because some insurer has already covered a portion of the cost before the invoice was generated. So for our particular use case, we need a strategy for each of our 3 business fields. For the vendor name, we know that this is hardly ever explicitly annotated on the receipt, so it won't show up in our key value pairs, but what we can say is that it's nearly always the header. And so we're going to make an assumption that the first line item we find in our list of raw text is the name of the vendor for the receipt. It's not perfect, but it's a good place to start. For our total amount chargeable, we know that this nearly always is explicitly tagged, and so we're going to use the forms section to search for any keys which contain this word total and look like a final total element. We're going to have to be careful about excluding or otherwise ignoring these red herring fields like subtotal, which might lead us astray. For the date, we know that in some cases that will be explicitly tagged on the receipts with something like date or today's date or transaction date, whereas in other examples, like this one on the screen, it won't be. And so first we'll try to use the key value pairs that TextRact gives us to extract the date, and if we don't find any keys that look like they contain what we want, then instead we're going to take the raw text and forward it to Amazon Comprehend, whose detect entity service is going to be capable of detecting and extracting date-like objects from general unstructured text. And so in this way, we've managed to come up with a strategy to get to our 3 business-level fields using some quite simple logic-based transformations. And so the way we're going to implement that is just in a small Lambda function, which for the most part is interpreting the TextRact response, and has this small additional dependency on Amazon Comprehend for that little extra bit of date extraction that we'd like to improve. So now that we have pre- and post-processing, the next question becomes, how do we want to orchestrate these components together, and how do we make our business process behave in situations where it's facing the unexpected? Although it's possible to build point-to-point integrations between all these components, like connecting recognition to our TextRacts and then sending results to our Lambda function for post-processing, we might consider orchestrating this process in such a way that we can make the components more modular and be able to adapt our business process at a higher level. A great idea for that is to use AWS Step Functions. In Step Functions, we define state machines by way of JSON in specifically Amazon States language, and these state machines consist of a series of linked steps where each step could be a task, like a Lambda function or some other native AWS service integration. It could be a decision point, or a final rejection or success state, or something else like a wait for a specific period of time, or even a pass state where nothing's done. Now, defining these steps gives us the ability to represent our state functions graphically, and also to track executions of these state machines, which is quite flexible for setting up pipelines comprising perhaps complicated sets of steps that we want to orchestrate and easily amend. So in this example, we've set up our pipeline pretty much as we've already described. First, we'll send our images for pre-processing with Amazon Recognition custom labels. If that labels the image as bad, then we're going to reject that image straight away. But if it's allowed through, then we'll forward the image on to Amazon TextRact. Those raw TextRact results will go through to our post-processing Lambda function, which might call Amazon Comprehend for a little bit of extra date extraction if it needs to. And then finally, the result from that will be our high-level business fields of vendor, date, and total amount. And we'll be doing a quick check to see whether we've managed to successfully extract all three fields, and whether we're happy with the confidence with which we've been able to do that. If so, we're going to mark our process as a success and proceed on to whatever the next stage would be. If not, we're going to reroute this document for human review, along with the predictions we made so far with our model, to let us have a better quality control and the ability to embed human reviews into this process. We can implement human reviews using the Amazon Augmented AI service, or A2I, which is part of the Sagemaker platform. In Amazon A2I, we implement review workflows which combine a set of people to do the reviews, a workforce, a task template defining what a review looks like, what it involves, and a destination, a location in S3 where the results of each review are going to get stored. Now, our workforces can be vendor managed, procured through the AWS Marketplace. We could use the public cloud through Amazon Mechanical Turk, or we could also define private teams using private workforces, which are linked to Amazon SageMaker Ground Truth for anybody who's familiar with using that. Now, our private annotation teams don't need access to our AWS console, because we can use a simple AWS SSO-based portal for them to log in and do their job. So I'll log in as a quick example here, using my separate credentials different from my AWS sign-in. What we see in the labeling portal is a combined view of any SageMaker Ground Truth tasks we have outstanding and any Amazon A2I review tasks that we have. Here I see there's nothing in the queue so far. So that covers off the components of our pipeline itself. Next, we can use a simple AWS Amplify-based web app to upload a document into this pipeline and watch it go through and see where we get to. So over here I have a small web app that we've created with a little bit of a sign up front because we are exposing S3 upload functionality, so we need to have a little bit of security there. And once I'm logged in, I'm presented with a pretty simple UI, just inviting me to upload an image. So we'll start out easy, and I'll give it an example which doesn't have a receipt in at all, and so it should be a fairly straightforward rejection to refuse to process. What's happening here is that our user interface is uploading that content to Amazon S3. The S3 object upload is going to trigger an execution of our step functions pipeline, and then through CloudWatch, the execution logs of that step function are going to be propagated back down to the user interface so that we see updates in near real time, but with a small lag. So I see here that the image was rejected, which is what we expected, because it didn't meet the standards for processing. It doesn't contain a receipt, so it's obviously not what we want. In fact, if I go into the step functions console, I can also look at the execution history and see that our most recent execution failed, and I can map that execution for the route it took through the state machine. So here we see that an error was caught in the pre-processing step because we didn't reach the required level of quality, and that triggered us to head down to rejection. So let's try uploading a more useful image. And in this case, we're going to see a receipt which should be processable. Again, the user interface is just going to upload this image to an S3 bucket, authenticate it with Amazon Cognito to give us that service access, and then that's going to kick off our state machine to start analyzing the document through the flow we've designed. If we go over to the step functions console, we can check our execution list to see this event being triggered in real time. And here we can see, in fact, that the execution was already allowed all the way through. So really quick progression there. We were able to send it to TextRact, the post-processing happened, and we met the confidence threshold, so the execution was marked as a success. If I go back to the web UI, I should see that the user interface is updated with the status, and we see the vendor, the date, and the total that's been annotated here. But there's a small problem. The total that's been tagged here is actually the subtotal field, and we've incorrectly annotated as $16.50 instead of $21.73. So of course we could address this by improving our post-processing logic, but one way we might address it as a simpler sort of short-term measure is to simply raise the confidence threshold for which we allow results through versus routing them to human review. That's quite straightforward to do in our step functions console. We can simply edit the state machine, find the definition of our check confidence stave here, and I can see that it's a simple comparison for the confidence field to be bigger than 40%. Now, of course, 40% is pretty low, so we can bump that up to 50%, save the state machine's configuration, and go back and even upload the same image again. And this time we should expect it to be routed a little bit differently. So again, returning to the step functions console, you can see that our execution has been triggered and is now running. And this time, because our check confidence stage had a different outcome, the object's been routed for human review. We should see the same thing in our web UI. And if we go over to our Amazon A2I portal and refresh the page, I should see that I've been assigned a new human review task. So let's start working on that. Here we see the user interface that we designed in this case, a custom flow. So we're showing the receipt image that we like to be processed, and we've pulled through those business level fields that we extracted, the vendor name, the date, and the total, including the annotation from the underlying model. And we've also set up some confidence bars here to indicate how confident the model was in each of these fields. And in this case, I can see that because the confidence bar is quite high for the vendor name of Egg Harbor and the dates, I can have some trust that the model has extracted these. But here the confidence for the total is significantly lower, and I can see that yes, this is the field that I need to override. Of course, this is a nice tool for focusing worker attention if you'd like to save their time, but it also carries risks because the model might be confident but wrong. One final thing that you can see we've done in the user interface here is it's possible to use this human review process to collect data for other machine learning tasks in future. There's no concept of the tax amount in our models today, but here we're using the human review as an area to simultaneously collect data for future modeling exercises. So I can enter the tax item in here of $1.93, or alternatively I could just be lazy and claim that it didn't exist. Now all my tasks are done. If I go over to our web UI, it might take a few more seconds to update just while that change propagates through from the step functions to the user interface. And here this time I see my vendor, my date, my corrected total, and we've also pulled through here the ID of the reviewer that took on the request, which of course isn't something you typically publish through to your user interface, but might be a useful thing to use downstream in your processing. So here we've seen a nice example of how Amazon TextRat can be orchestrated together with pre-processing via Amazon Recognition custom labels, with some basic post-processing to go from the raw TextRat results to our business level fields, and with a human review step using Amazon Augmented AI to maintain consistency and reliability in our process. Orchestrating the process via step functions gave us a nice configurable workflow that we can change easily, and setting it up with a nice little web UI made it easy for us to demo. So I think that's all we wanted to show you for TextRat at the moment. Back over to you, Bernard.
Thanks for the extensive demo, Alex. I hope you have now a clearer idea of how we can incorporate the different AI/ML services as part of your document processing pipeline. Here's a quick list of customers who have automated significant chunks of their claims process using TextRat, Sagemaker, and A2I. For example, Cox Automotive and NIB uses Amazon TextRat to process millions of documents in a process very similar to the one we just demonstrated. We have also seen document digitization making a real impact in the healthcare sector, where Change Healthcare and the United Kingdom and National Health Service, NHS, have used TextRat to process healthcare claims and other documents at scale. Lastly, Ripcord uses Amazon A2I and TextRat as part of their process to help their customers convert vast paper libraries into secure and searchable electronic documents. Later, Alex will show us a demo of how Amazon Kendra can be used to build searchable document indexes that can be accessed using natural language questions. Next, Let's talk about the possibilities from document digitization in enhancing your company's research capabilities. We can start by thinking about the flow of data throughout your teams as they build knowledge-based insights. Let's look at the third challenge, where document processing may not necessarily be directly driving your costs, but still presents a key operational barrier. In this case, we'll need to look at any knowledge-based firm or department that's often tasked with building reports and driving insights. To do this, your team would often spend a significant amount of time researching and compiling data from internal and external sources. What are some of the key issues you would see as a result? Chances are, internal knowledge and resources are fragmented and siloed, making it hard for teammates to research effectively. It's also likely that during the manual search, they will miss out key information. If you had teams doing similar projects, it's also likely they will use up billable hours repeating the same work. So just think, how much of your team's time is spent researching and compiling information and not actual analysis? Next question, how much work is actually repeated amongst different project teams? Lastly, with this extra bandwidth, what new insights and innovations would your team be able to drive? Let's look at a reference architecture for machine learning-based document search. User can input documents into an S3 bucket, triggering a Lambda function to run TextRack API to extract data, for example, key value pairs and tables. The output can be stored and indexed into your document management system, for example, Elasticsearch. Alternatively, you can build a smart index using Kendra to help your employees find the information they need using natural language queries. Essentially, this allows employees to type in conversational type questions to get the relevant answers they need quickly. Later, Alex will go through a demo to show you how quick and easy it is to set up and use Kendra. I would like to share a quick list of customers who have used TextRack to process documents faster in order to improve their research capabilities. In here, Alfresco uses Amazon TextRack to extract data of interest from their customer documents, automating data entries and creating new insights. And these customers have also used TextRack as a key tool to maximize the research capabilities of their research team. For example, in one of the examples here, PitchBook is a leading provider of data in private capital markets. They use Amazon TextRack to improve the processing of their PDFs as part of their research process by as much as 60%. Here's a quick list of customers who have used Kendra to enhance their research capabilities, allowing them to focus more on driving insights. For example, Sage is a provider of business management software and services, and that includes accounting and payroll, finance and operational management, HR and people management, and customer relationship management. And with more than 3 million customers worldwide, they use Kendra to help improve their customer experience by directing customer queries to the relevant documentation where needed, allowing customers to quickly access the information they need. Now, I will hand over again to Alex to do a demonstration showcasing how easy it is to set up and use Kendra. Alex, the floor is yours again.
Thanks, Bernard. So let's assume we've digitized our content into some searchable format, maybe even using something like the official Amazon TextRack searchable PDF sample from AWS Samples. I'm going to walk through the process of getting that content into Amazon Kendra to be searchable and show you some of the advanced query understanding functionality that's going to differentiate Kendra from some of the sort of traditional search engine technologies. So let's dive right into the Amazon Kendra console. And it might look a little bit different depending on whether you've used Kendra before. You may be taken directly to the indexes list, but either way, we're just going to click on the Create an Index button. I'm going to give my index a quick name and a description. And I'm going to let Amazon Kendra create me an IAM role just so that everything is easy. Maybe even name it after that index name as well. I don't need to set up any indexing or any encryption or tags for this use case. What I do need to bear in mind is the provisioning choice. So the key thing here is that the developer edition runs in one availability zone only. So we don't typically advise running production workloads from the developer edition, but for small experiments and POCs like we're doing here today, where the sort of quotas on documents and queries, which might be a little bit different from enterprise, are fine, developer edition should be no problem for our use case. Now, because we're creating an IAM role, that's going to give a little bit of time for the permissions to propagate, to check it's okay. And then as soon as that's done, it's going to start creating the index, and it's going to show us back to the Amazon Kendra console. The key thing here is creating an index is something which can take a bit of time. I think you'll see in the banner it says allow up to 30 minutes. Often it's significantly less than that, but not always. And the reason is we're spinning up all the infrastructure necessary to support these query capacity, to deliver some sort of document ingestion work, etc., etc. But while that's going, we can still take a walk through the functionality and sort of upload our content, getting ready to go. So you can see here I've been taken to this overview page where there are these 4 key steps I need to bear in mind. The first is creating an index. That's already in progress. The next thing we're going to do is add our data sources to actually upload our content. And then actually, before we test it, we're going to upload some FAQs as well to sort of see that functionality in action. And then we're going to look at testing the search in the Amazon Kendra console itself and think about how to deploy it to our own website. So just walking through the data management key tabs down here, where the key area where we're going to maintain our index. The first action is this data sources, and we're going to use Amazon S3 just as an easy example to get started quickly. But if you have content in SharePoint, OneDrive, Salesforce, and so on, you can use these pre-built connectors to port that directly into Amazon Kendra and connect that content in. If you have any content in other sources where, of course, you don't see them in this list, but you would like to support for a direct connector, then of course please do let us know. We're always interested in feedback about that, where we should prioritize these efforts to scale this out further, what will be most useful. And of course there's always the option as well to build connectors which get that content into S3 or RDS first, or any of these other sources, and then Kendra can sync directly to those. As well as these sort of content itself, the documents, the things that we're going to index for search, we're also able to upload FAQs, and these are specific treatments for known questions that we might get asked. So if you see some kind of question case which is really commonly asked to your collection, and it's not really directly served by the content, but you have a specific way that you'd like to treat that, that's an excellent use case for the FAQs. And these are just going to be a small little CSV that we upload later on. We'll see that in action. And then finally, there are some extended functionality here where we're not going to touch much on today. You can do things like defining metadata for all of the content that you upload, and then use that metadata to do things like providing facettable search results, and also to tune the accuracy of the Kendra search. For example, prioritizing fresh or recently changed documents or not. And so we're not really going to touch much on this functionality because we're going to be focused on the out-of-the-box performance of Kendra, but plenty there to go and have a look at too. So what content exactly are we using for today? I'll just show here. So what I have here is a list of academic papers in the field of machine learning, and you'll see that many of these are sort of informed by the algorithms we see being used in AWS services. So DeepAR, for example, being used in Sagemaker and Amazon Forecast. Blazing Text, also available as a Sagemaker built-in algorithm, etc., many of those. And alongside those papers, we have some of the service docs themselves, also extracted to PDF. So you can say I have Amazon Comprehend in here, Sagemaker, not an exhaustive list, but just a few examples. And finally, up at the top, we've got some free ebooks that were released earlier this year, again, in the domain of machine learning and data science. Now, most of these are introductory. We split them into chapters, and they're just nice little resources to get started on data science and machine learning. So we're going to be building here a model which is able to ask these introductory questions and get some nice answers for getting started with ML and data science. Also here, there's the FAQ spreadsheet. Now, this isn't very big. We just have 3 examples in there, I think. And I'm not going to open it up fully, but you'll see the structure is quite simple. We have the question that we expect to be asked, the text of the answer that we'd like to show, and then over here on the right-hand side, we can also point out a URL that we'd like to send people to if they'd like more information. So this is an example of how it's great for off-topic questions where we would like a specific treatment. For example, how's the weather? I wouldn't expect that to be in our corpus, but it's here in the FAQs. So all I'm going to do while the content is uploaded, sorry, while the index is creating there is upload that content to S3. I'm going to create a new S3 bucket first over in the S3 console. Digi content, and now all the settings can be as defaults. And then I'm going to start by uploading just that FAQ spreadsheet. And one best practice that I'm going to do here is to create a folder just to keep my FAQs separate from my content itself. Because you can imagine these are kind of two different kinds of data, as we saw in the Kendra console. And we have our sort of documents themselves, our content that we're going to use to search on to generate responses, and then we have those specific tailored responses for certain use cases, the FAQs. So it's good practice to keep those just a little bit segregated so that we have an idea that they're different use cases and different inputs typically as well. One of them is going to be manually curated, maybe the other one is just a connector to a data source. And so those are now uploading. You can see in the S3 console, my Kendra collection is still creating. You can see my index is now created and in status active, so we're ready to go with adding our data sources. As we said before, lots of connectors to choose from, but we're going to be using Amazon S3 for this example. So I'm going to add a connector, and we can have multiple data sources associated with an index, but in this case we're just going to have one. So our data source name doesn't really matter too much, and likewise the description. What I'm going to need to provide is a bucket where my data lives, because we're in S3, and you can see I have this over here. And we're going to get asked for where our metadata files live, but of course we didn't upload any of those, so I'm going to leave that blank. And in this case, because we're using a bucket that we've created ourselves, I'm going to let Kendra create a new IAM role that I know then is going to have access to that bucket, because of course we need to give Kendra permission to see what's in there. The final bit of config we're going to do down here is the additional configuration to say, as we set up previously, I only want Kendra to call the content folder and ignore anything else that it might see in that bucket. And although we didn't talk about it before, because I uploaded this content directly from my laptop, you might be able to see there's a few of these pesky little DS store files floating around in here from my desktop. So I'm going to explicitly ignore those rather than have them potentially crop up as sort of reported skipped files or errors. And I'm going to ignore those anywhere they might appear. Very good. And finally, because we're just doing a little one-off experiment here, I don't need this to run regularly on a cycle or anything, so I'm just going to ask it to run on demand. Short little review screen here, and we should be good to click create. Now again, because we're creating a new IAM role, that's going to give that a little bit of time to propagate before it pushes us forwards and back to the Kendra console. And the key thing to point out here is that we're creating this data source and connecting it in, but we've requested this run-on-demand scheduling here, so it's not going to sync to the content in S3 automatically. We're going to have to remember and make sure that we click sync now to make that happen. What you're going to see is that the actual creation process for the data source is fairly quick. And there we go, it's active straight away, so I can click the sync now button already. And while that sync is happening, I'm going to go quickly over to the FAQs page and start uploading my FAQs content as well. So very similar process here, add FAQ. Again, we're only associating one, so the name doesn't matter too much. And I'm going to set this time the whole S3 path to where that data lives, which of course is Digi content, and then you'll remember the FAQs.csv. And of course, we just created an IAM role with access to this bucket, so I can use the same one again. And I'm going to leave all my tagging as default. Now again, we only have 3 FAQs in this sample, so hopefully that's going to be very quick to become active. What you will see with the data source syncing, which is still going on here, I can see, is that the time is a little bit variable for when this can become ready. Sometimes it's very fast, might already have been done by now. Sometimes it takes a little bit longer, as it is doing here. There are 2 processes going on here. The first one is to crawl the data source to see what files have been added, deleted, modified, and so on. And the second one is this actual indexing of it into the collection to make it searchable and good. I can actually see here it's already done even now. There you go. So we've managed to add 161 documents. Now that we've done that, we can go up to our console here, and whether it's from here or from over on the sidebar, we can go and experiment with our console in the Amazon Kendra UI. So what I see here is an example search interface for how I might deploy Kendra into my own application. And I can ask queries and receive answers as I would normally. So let's start with something nice and easy. We want to see the DeepAR paper. And this is the paper I mentioned before for the algorithm that powers Amazon Forecast, and also available in Sagemaker. And you can see here I see a ranked list of search results with titles, snippets, the usual things you might expect from a search engine. And if I open up that link, I'm hopefully going to be taken to the content I expected, which is the academic paper describing the DeepAR algorithm. So excellent stuff. I like that result. I'm going to give it a thumbs up. And over time, I can actually use these reactions here to automatically tune Amazon Kendra's search relevance in the direction that I want if I'm having some issues with that as well. So we can move on to something a little bit more challenging than that, I think. For the next one, let's try unsupervised versus supervised. Oops. And this is a common question that will crop up in a lot of sort of ML 101 data science topics. And you can see here that what's happened is above the raw search results themselves, I've had this Amazon Kendra suggested answers box generate, which shows me not just the sort of links back to the documents, but this extended document passage where it talks about probably the answer to this question. So you can see here it's talking about what's distinguishing supervised from unsupervised learning, a little bit of context around the description of those two things. And if I go, I can page through a couple of examples here. This one, maybe a different chapter, a different book. I think it may be a little bit clearer even here in contrast to the term. It goes on to describe supervised as well as unsupervised. So I'm going to give that a small little thumbs up there to say that's the answer I prefer. And again, there's a third option over here as well. And the key thing here is that we're not just pulling back passages which talk about supervised and unsupervised learning together. We're kind of using our understanding here of the fact that this versus, even though it's not a term that we'll see in this academic literature, is expressing that we're interested in the contrast between these two things, the differences. So we're kind of understanding a little bit about the question to help prioritize the answers here. We can go a step beyond that, of course, and ask a really specific question with an answer which appears in the text. So, for example, when were LSTMs invented? Now what I see being pulled back this time is not just a passage with this sentence highlighting here of LSTMs invented in 1997, but because the sentence here so clearly and explicitly answers the question that's been asked, Kendra has been really confident and pulled that out up to the top and said, hey, look, big, bold writing, I think 1997 is the answer that you're interested in. And here's the passage where that comes from, and here's the link to the document if you'd like to go and explore more. And of course, that document itself is a whole book chapter, right? So we're not just talking about little silly bits of information here. It's extracted it from a big block of text and been able to get me directly to the answer I needed to see. Now, that can really boost my productivity as a user because I'm no longer hoping for things to show up in really small search snippets. I'm no longer having to drill through to these big documents to go and explore the answer to my question. I've got these really attention-grabbing mechanisms to display these deep contextual answers to the question I've actually asked with reference to the content which is available there. So really powerful stuff from a business value perspective. We can even try something even more challenging because I can see this sentence here. We could maybe ask, for example, who invented them? And hopefully we're going to see, there we go. So it's the same passage being brought back again, and we can see actually it's highlighted exactly what I wanted to see, which is the duo that were credited with the invention themselves. So, and that's really difficult because, of course, we've omitted the key noun there. So any search engine is going to struggle with this because we no longer even mentioned the LSTMs is what we're interested in. Kendra has just managed to remember that from the context of our query before to present us this nice answer here showing exactly the information we wanted to know. And of course, because this question is so difficult and so ambiguous, we've not been so confident as to say, hey, here's the answer, big flashing lights up at the top. But we have still got to the correct answer, and that's going to be really useful for sort of me as a user to get to where I want it to be, even just with this little implicit question. Now, the really cool part here is that we've not had to train Kendra on any of these concepts. We've not had to talk it through, the sort of who, what, where, when style questions. I can ask other things too. So for example, I could say, what does SSD stand for? So an acronym style question. Hopefully I'm going to see here a result that, that pulls back, a highlighted list of it's a single shot and maybe multi-box detector, different definitions, whether you need multi-box in different books. But it's going to pull that back without me having to have taken any time to train these things into it. And that's a really key difference in terms of what we might be used to, is spending a lot of time training and refining these search engines. Of the benchmark performance that we get straight away is really good. And of course, for anything where we don't have these explicit answers to the questions that we're asking inside our content, we can fall back and use that FAQ functionality. So if I say, what's the weather like? I'm hopefully going to see, again, above all my search results here, this FAQ function that I uploaded before in my CSV, where I can show this little short answer and then direct people to an alternative URL as well. So anything where we see this question coming up regularly and the content itself doesn't quite serve it well, but we would like a specific treatment for that, excellent use case for FAQs. So that kind of is a quick tour through some of the cool question understanding that Kendra is going to give us straight away just from uploading our content. You can get a feel for the fact that the user interface, how we present these results, is a little bit important. And so if you go over to the Deploying Amazon Kendra section of the developer guide, you'll see there, in fact, some source code available for React.js UI components to sort of use as an inspiration or a basis for building your own components. And of course, if you're using a framework other than React, you can just use this as inspiration, or indeed look at the Kendra console itself as a kind of guide as to how you might think about introducing these and integrating them. However you want to actually end up integrating with the APIs, you could show slightly different user interfaces. But the really key value here is going to be that if you can show these high confidence answers to your users and make them attention grabbing and make them easy to use, then you'll be getting really significantly different value out of it than you would be out of a standard search engine where you're just presenting a list of results. That's pretty much all we wanted to go through from Kendra today. So thanks, and back over to you, Bernard.
Let's go through the 3 quick implementation scenarios for TextTrack. Thank you for your time so far. Let's recap here. The biggest issue we want to address is the massive time commitment needed to process documents. In turn, this takes up significant employee time, driving costs upwards. For knowledge workers, the significant lag inherent in document processing represents a significant barrier to coordinate research efforts and building necessary insights. This is where we come in. We want to help you to free up your manpower to drive innovation and customer value within your company. Avoid the high fixed costs and overhead necessary to process documents en masse. Greatly increase the reach and depth of your knowledge workers, allowing you to drive faster, more comprehensive insights. Regardless of your use case, AWS provides you with the tools you need to build a document digitization solution. Regardless of your comfort level with machine learning, AWS and its partner network are keen to support you on your journey. Let's look at how we can support you throughout your journey. Our business development and solution architect teams can work with you to explore proof of concepts. From this point, you may choose to drive the project internally or work with our partners in our trusted partner network to help you build and deploy your intended solutions at scale. Alternatively, some of our partners may arrange to set up to provide the service under a SaaS arrangement. Regardless of what your comfort level with AI/ML, we can provide the necessary support. And do stick around to ask any questions you may have with Alex and myself. If you are interested in learning more, visit aws.training/machine learning to explore the learning paths, including digital training and instructor-led classes. You can also validate your skills with AWS certification. We hope you found this session helpful. If you would like to know more about AI and machine learning, visit our resource hub to get access to the newly created resources that will help you learn more about AI and machine learning. This brings us to the end of the first session. If you are interested to learn more about what I've discussed today, there are several options available to you. Thank you for attending our session. I hope you enjoy it, and please remember to complete the survey. Let us know what you think and how we can improve the event experience for you in the future. Thank you, and we look forward to speak to you again. Now for the Q&A.